All right, let's get started. So we have Kira, George, Rahul. Today, if you can see my screen, Rahul and Kira and George, we're going to be revising what we've talked about so far because we've done linear equations and linear inequations. So we're going to summarize everything by going through the steps again. Now, you might see something that says Raymond Tulsi Volume 1. I scanned the entire book for you. So if anyone doesn't have the book, right, let me give you the link to it. If anyone doesn't have the book, you can just follow along with me with the soft copy version of the book that I prepared for you. So there's the website. Let's get started. We can't wait for the rest of the students. Let's get started. So when you click on the link, you're going to see linear equations, linear inequations, and homework. Pretend that the homework doesn't exist for right now. We're just going to look at exactly what we've been talking about for the past week or two. Okay. So firstly, let's understand how linear equations and linear inequations look. Okay? That's the first step. All right. Okay. All right. Can you see the graph? Okay. So if you're looking at the graph, you'll see that the linear equation graph only has a line. It's defined. But the linear inequation graph has a line, but every other area underneath the line is in pink. So that means it's a boundary. You understand? So that's the difference. With linear equations, you're telling me where the points are. With linear inequations, you're telling me where the boundaries of the line is. Understand? Look close at the graph, you'll see a pink boundary for the linear inequations. Does everyone see that? Welcome, Parab. Welcome.
Yes.
All right.
Hi, sir.
How you doing? How you doing? All right. So let's quickly, here's a virtual notebook, Parab. The soft copy of the textbook is prepared for you. It's called Raymond Tulsi Volume 1. You can go on it and follow along with me. We're at page 261. Okay? So now we're looking at how the graphs look. So we're taking a step back and understanding what exactly the linear equation looks like and what exactly linear inequations look like. All right? There's the graph. With linear equations, you only have a line. Linear inequations, you have a boundary of the line. Let's move on. We have to continue. It's just a summary what we're doing. All right, let's go. Let's continue. So now, we start off by solving a linear equation by telling you that there was a variable that we wanted to find. Does anyone remember the variable name? The variable name? It was x, correct? Right. So if you want to find x, then you have to tell me what value surrounds x. And we represented that value surrounding x in an equation, right? Where a and b were real numbers and x was the unknown, right? Now, using this formula, which is ax plus b is equal to 0, right? That essentially told you how you could have gotten the line of the linear equation. Everybody remember that?
No, sir.
You do not remember that. All right, let's go over it then. This is what this class is for. So, since you just joined, we're summarizing everything that we've been going through for linear equations and linear inequations. So click on the website, you'll see the textbook in soft copy for you, prepared it. So we're just talking about what linear equation looks like. Can you see the graph?
Yes, sir.
So linear equation is just a line. But we're saying now, compared to linear inequation isn't just a line, it's a boundary. So you see where the line is and then you see some pink region after the line? On the linear inequation, the right side of the graph. Do you see that?
Sir.
That's telling you now that it's not a point, it's a range of points. So it's a range of, it's the volume 1 textbook. So let me scroll up. So when you click on the purple link, it'll take you to the virtual soft copy of the textbook. 400 and something pages, right? We're on page 261. Okay? Page 261. See, it's right there. Come on, guys. Page 261. Let's continue. Right. So
I don't know how to use this website. Where is everything? I don't know.
When you click on the website, all right, look at my screen share for now because it's the same thing that's on the website. The website is for your individual study time, but I'm presenting the screen anyway. So it's not like I say you have to go on the website right now. Look at my screen. So now, the graph is represented by a formula. We stated that when you have a formula such as this graph, when you're trying to plot it, you have to have x. X is our unknown, correct? Correct, guys, right?
Yes, sir.
So if we want to find x, we had to have been given some real values, such as a and b. So we represent the equation to find x by ax plus b is equal to 0. All right, so I see that everyone is here now. Let me take register quickly. All right. Okay, let's continue. So now, understanding the equation and understanding how the graph looks, we moved on to operate using the equation. So we said, well, can I add 2 x's? Can I subtract 2 x's? We looked at this, and let's go to the operations. Right, there we go. So we talked about addition first of all, right? Let's quickly go to addition. All right, can someone work this out for me? So we're saying x plus 2 is minus is equal, right?
5.
Right, x plus 5. Right, exactly. So if you were to move over that 5 now to make x equal to a value, would it be positive 5 or negative 5? Right, look, x plus 2 minus 7. That's telling you now that, remember, the equation is, to make a line, it has to be equal to 0. So we're going to say x plus 2 minus 7 is going to be equal to 0. Right, guys?
Yes.
So now...
So wouldn't it be x equals 7 minus 2?
Right, that's the same thing as x is equal to 2 minus 7. Right? So that would be negative, so x minus 5 is equal to 0. Carrying over now that negative 5 over the equal sign to make x a value, what would it be? Anyone remembers? So you're going to say x minus 5 is equal to 0. X is equal to 5. Anyone remember that?
Yes, sir.
Right. So take that note for me because I want to see you writing. So you're going to write the formula, which is ax plus b is equal to 0.
We should write off first.
That, yeah. You can write this note in your individual time because you'll have access to the notes after class. But for now, you're just going to write the formula for me. Ax plus b is equal to 0. Right? If after you write the formula, you're going to say using the addition operation, so we're starting back from square one because I want to make sure you understand. All right, so we have 12 persons in 10 persons in attendance. 11 now. Okay, good. So using the addition operation on linear equations, such as x plus 2 minus 7, we have to state that based on the formula, to make it a line, it's going to be equal to 0.
Sir, you're going too fast. I did not write all.
All right, it's on the screen, so you should be looking at the screen with me.
Where is it, sir?
On my share screen, can you see my screen right here?
Yes, sir.
All right, so look at operations on linear equations. Let me bring that up more. All right.
Sir, I mean you said write ax plus b equals 0 using the addition operation.
Right.
Then I didn't hear
all right.
the rest. I don't see it on the screen.
All right, let me go back. So look for me. So here's the equation. Ax plus b is equal to 0. That's the equation we're using.
Yes, sir, but I can't find the sentence on the screen.
No, so I'm saying the sentence based on the notes because I'm summarizing the notes, and then in your own time, you're going to go back over this and make sure you understand. That's how we do it, right? So I'm telling you what the note is essentially stating in a short version. So you're saying using the equation ax plus b is equal to 0, we can create a line on a graph. So let me type it out in chat. I want you to let me type it out quickly. All right, we're on a, so using the, I'm saying it already, so I don't have to type it. Everyone reach there?
No, sir.
All right, let me give you a moment. So using addition operation, all right, so ax plus b is equal to 0 is our equation. All right, so we have 14 persons here. That's a lot. Okay. All right, let's continue now. The first operation is addition. Okay. All right, let's move on. Scroll down. Now, what do you think the second operation would be?
Subtraction.
Right, so let's go to subtraction. Let's close up the addition. Let's go to, there we go. All right, can you, all right, so you should be able to see the subtraction now. So we're saying now that,
No, sir.
It isn't showing? One moment.
It's not showing.
All right, let me read those. All right, it should be showing now. Okay. All right. Apparently the screen froze. Let me reload it. One moment. All right, there we go. There we go. All right. So do you see now?
Yes, sir.
All right. So this is the second operation on linear equations, subtraction. So we're not adding, we're subtracting. So in this case, we have an example, x minus 3 is equal to 8.
X is 11.
All right. Great. That's correct. So that's the second operation. Everybody understand how you got 11?
Yes.
All right.
Yes.
All right, let's move on now. So the third operation, that was weird. It jumped off. So the third operation right there is multiplication. All right, so my screen reloaded. My bad. So the third operation is multiplication. And we're going to write this example. Let me reload the screen one more time. All right, there you go. So multiplication. Everybody have that? Here's an example. It's loading up. One moment. Give it some time to catch up. All right. All right. Now, in the third example, we're not using addition nor subtraction. We're going to say now our value A is multiplying on X. Let's look at that value now. So look at my screen for me.
Yes, sir.
All right. Now you should see. Okay, let's go on it. There we go. All right, there we go. So we're on multiplication now. You should see an example. 5x minus 35 is equal to 0. 5x minus 35 is equal to 0. The first thing that we have to do is what? We have to carry over the minus 35 over the equal sign. What would that give us? Positive 35.
7.
Perfect, she got it. So you carry over the 35, that makes it positive. Then you divide both sides by 5. That makes it equal to x is equal to 7. So that's the third one. Let's go back now to the fourth one, which is division. Right? Now, in this example, x minus 6 is equal to 5. Can you hear me? Right. Right. That's a fourth one. Now, what if though we're not worrying about specifically any multiplication? What if we have x on both sides? What did I say you should do? You should group the terms, right?
Yes, sir.
All right. So let's look at an example. So let's go on the textbook. All right.
So will you upload the pages on WhatsApp?
Right. I'll send you the link to the textbook. That's what I'll do. Because I scanned the book, right? So I just want you guys know to have this at your resource. So now you're gonna say, what if we had 8x?
Sir, you scanned 723 pages.
You see my dedication, right? I'm very serious when it comes to making sure you guys.
Thank you, sir.
You're welcome. So now you're gonna say 8x is equal to 40.
So mine doesn't work. Like when I click it, it says error, and I keep after refreshing it.
All right, I'll figure that out for you. No problem. Now we're gonna say 8x is equal to 40. Can someone solve that for me? Right. That was division. What if we had now 7x, right, is equal to 3 plus x? How would you solve that?
7x and what?
Is equal to 3 plus x. So you have an unknown on both sides. How would you solve that equation for me?
So you group the x's.
Right. So group them and tell me what you get.
And then you do the operations that needs to be done.
Okay.
Half.
Perfect. Great. So now we've completed 6 operations.
Wait, I have a question. How did you get a half?
All right. Let's go.
You take the x from the right hand side, and then when it goes to the left hand side, which means it's gonna go with the 7x. Since it's a positive x, it's gonna be a negative x. So 7x minus x is 6x. And then you take the 6 from the operation will become opposite.
All right, let's go back to the steps. Come on, let's go back to the steps. What was the question?
7x equals 3 plus x.
Right. So you would carry now that x over, and it'll be 7x minus x. Correct? So now it'll be 6x is equal to 3.
Do you have to keep the x positive most of the times?
Right. Your prime directive is to make x positive, because the question said solve for x. It didn't say solve for negative x. So now you would say 6x is equal to 3, right? And what would you do now? You would divide both sides by what?
By
both
6.
Right. So now you would have x is equal to 3 divided by 6, and then you get x to be a half. Everybody there?
Yes, sir.
Right. If you're not speaking to me, can you mute your mic? Right? Okay. So now that was the unknown quantity on both sides. So we just completed an unknown quantity. That's the topic that we just completed. Now we're moving on to what if we have brackets in our inequation. So it's not a case that we have x and we need to group them. What if
we have
x?
to solve the brackets first.
Right.
Yes, sir.
And what was the law that I said you use? You use the distribution law. Right. So let me share my screen on my second one. Look at my screen for me. All right. Right. So look at my screen.
So what do you like
to share two devices at the same time or something?
I was about to figure that out, but I'll say, you know what, I'll figure it out next time.
So I know how to do it.
Yeah, I figured it out earlier today. Okay, yeah, there we go. I figured it out again. Okay, look at my screen. Let me share my screen. All right, let's go here. All right, so look at my screen. Don't look at Davin's screen. Look at my screen, Mr. Thompson's screen. All right, look at this for me. Now, you should see the distributive law come up. Do you guys see that? Right here. All right. All right. Do you guys see that?
Yes, sir.
So now you see 3 bracket x minus 1. You're going to put that 3 and multiply each term inside the bracket by the term outside. So 3 multiplied by x gives us
3x.
3 multiplied by negative 1 gives us
-3.
right.